But just to introduce everybody to myself, so my name's Mike Dion, and I've been with Stiebel Eltron for 12 years now, and I'm on the technical side, part of the team responsible for bringing the WPL to the US. This heat pump product that we've been selling in Europe for a number of years now, but we thought it was a good time to bring it here to the US. Um, so would you guys introduce yourselves generally, or also if I could understand a little bit more about um, where you guys are coming from, particularly when it comes to um, air to water heat pumps and that part of the business?
Yeah, so do you want
Hey,
to
Michael.
step in there?
Hey, Michael, I'm Seth with
Hey,
Low
Seth.
Energy Systems. We've been a customer of Stiebel Eltron ever since Frank originally brought over the first tankless electric water heaters. So we've been involved with Stiebel for quite a long time and seen the ups and downs and changes and all that kind of stuff. And we're not involved with Stiebel as much as we used to be, but we're still realize the quality of the products that you guys bring over, and that this heat pump is a really exciting product, and it seems like it can do things that potentially some other heat pumps can't do. So we're really excited to learn about it and offer your product through our wholesale business. And if you don't know about Low Energy, we've been in business since 1977, and we're tanklesswaterheaters.com. We do a lot of tankless water heaters. And then back in the 90s, we got into hydronic heating and radiant floors and boilers, and that has transitioned into solar thermal. And now we've just become a kind of all-inclusive hot water solutions wholesale supply house. And we try to specialize in high efficiency equipment. And
Okay.
that's about it.
Great to hear. Okay, and so you're like over the past few years started to dive into the air to water heat pump market.
Yeah, that's right. We've mostly been using the electro boiler Nor Air product and
Okay.
combining with a Bosch Bova outdoor unit. And the Nor Air has been really good and worked well with its kind of large auxiliary boiler backup. We can get up to 20 kW integrated boiler backup in the Nor Air, and there's various sizes. And it definitely, we've sold, I don't know, a dozen of them potentially over the last couple of years, and it seems like it's a good product, but there are definitely limitations. And we see that this new stuff coming from Stiebel, being an all-inclusive and pre-engineered system with the tank, the outdoor unit, the indoor unit, it's exciting. So we're want to learn some
Sure.
more.
Sounds great. And can you remind me, so I mean so Colorado is your main territory, right? Are there any other states that you're involved with?
Yeah, I mean, our tankless water heaters we ship nationally, so that's kind of a
Oh, okay.
national side of the business. But from a standpoint of boilers and heating homes and radiant floors and all that, that's generally Colorado's our market for that.
Okay, gotcha. And like just the majority of the installed, or first of all, are basements pretty typical um in your area, or is it like more just like mechanical rooms on flat slabs?
We pretty much always have basements in our area.
Oh, okay, gotcha. Just curious. That's always good to know. Um, okay, so I guess let me just do ease this into the product here. And since it's a pretty small group, feel free to stop me if you ever have any questions. Sometimes with the bigger groups, it's better to just save everything for the end, but feel free to let me know if I haven't explained anything clearly enough, and happy to address it. So, what we're talking about here today, like you guys mentioned, is um, the integrated solution that we have for air to water heating for hydronic delivery. It's achieved using our WPL 15 and 25 A2W Premium. That's the name of the heat pump, the outdoor unit. And we have the HSBC 300 Integral, which is the combination tank that has a buffer and a domestic water tank inside. I'll show you a little bit later, more of the internals. And also the controller for the system. It communicates with the heat pump and controls that. And also a source pump and a heating circuit pump. So really, in theory, all you should need to do is make connections between the heat pump and the combination tank, and between the heating circuit and the combination tank, and all that work and the time and effort is saved for you. Just a bit of naming. We get a lot of questions about our sometimes obscure naming system. A lot of times the beginning comes from German. So WPL actually stands for Wärmepumpe Luft, which is just air source heat pump. And 25 is a relative heating capacity. It's really only good to compare it to other, the 15 is a smaller unit, 25 is a bigger unit. Doesn't really resemble anything, like it's not BTUs per hour or kilowatts or anything. So just keep that in mind. A2Ws for the water. And with our naming scheme, premium is the top of the line model with all of the highest efficiency components used, and comfort features for the user, and also ease of installation for the installer. And we'll see a little bit more about that. And as far as the naming for the HSBC, it's even more complicated and not really worth getting into, but I think the product stands for itself. So the outdoor units that we have two models that we've introduced here, the WPL 15 and the 25. And bottom line, the 15 is a 2-ton for cooling, and 25 is a 4-ton cooling, and 25,000 BTU heating, 50,000 BTU heating for the large unit. And these units are all self-contained monoblock units, so the refrigerant circuit's fully self-contained. The person doing the installation doesn't have to do any refrigerant work when they install it. There's 2 water connection ports on the back side that you connect to either the HSBC unit or a buffer tank inside the mechanical room or in the basement or whatever. And particularly in environments that are prone to freezing temperatures, definitely in your market, we recommend a glycol water mix just to bring the freezing point down a little bit. This unit has a lot of like antifreeze protection measures, but there's always the possibility that power goes out during a really cold spell, and having glycol in the mix there just helps keep you from having a costly repair once everything thaws out. So this monoblock design allows for compact outdoor installation. Like I said, everything's self-contained. With our premium model, we go for increased efficiency and reliability. What really stands the premium model apart from our lower tier designs and a lot of other air-to-water heat pumps in the market is the inverter-driven compressor, which allows for modulation of capacity. And I'll talk a little bit more about that later, but that basically allows mostly eliminates on-off frequent cycling, which is huge for both efficiency and for longevity of components. And that's huge. The inverter also allows for kind of a compressor soft start, so it's gentler on components from an electrical perspective, because the starting current don't have that big surge. You don't have, it's less likely to have lights dimming during those periods also. And along with this inverter driven compressor, The compressors that we buy from Copeland also have this enhanced vapor injection feature, which is it boosts the temperatures that it can deliver up to 149 Fahrenheit. And it's also helpful at lower temperatures where it increases the heating capacity at those lower temperatures, where a non-inverter driven or a non-enhanced vapor injection compressor wouldn't be able to operate the same. Expands the operating envelope essentially. And it can also, we have designed this to provide heating and cooling with a four-way valve. And that allows you, if you ever have if you want to do hydronic cooling, this allows that to happen. And the integrated controls, I'll talk a little bit about that later, but this is designed to be highly integrated with the HSBC combination tank, which I'll talk about in a little bit. So a little bit more about the enhanced vapor injection. On the left side, you can see the typical heat pump installation, which is mostly just a circuit with a compressor, condenser, expansion valve, evaporator, and those work great. But with ours, we've basically taken the liquid out of the condenser and split it into two streams and have an expansion valve on one of those streams and pass it through in reverse against the subcooled liquid that came out of the condenser and went through the other stream. And that heats, superheats the vapor coming out of the that's other expansion valve, and it injects it midway into the compressor, and that is what allows the expansion envelope to, or the heating envelope to be expanded and the capacity to be increased at lower temperatures. So it makes it a bit more complicated. This is a general overview also. The fact that it's reversible, allowing for cooling makes it even more complicated, but that's just the general overview. And this is more of a visualization of the expanded operating envelope. So on the right, you have a typical or a scroll compressor, two-stage, that well, these are the operating temperatures within the heat pump. This isn't like ambient temperature or anything, but it does expand the envelope. And like I said, it's down to -4 Fahrenheit ambient temperature and can deliver water temperatures up to 149. So just a few more features. Like I said, it can provide heating, cooling, and domestic hot water with the combination tank. You can provide all of your heating and cooling needs with one unit. The unit is designed to be really quiet based on how we designed the evaporator. The fins inside the evaporator are spaced to reduce turbulence and make noise. And also the fan modulates to only have the airflow over the evaporator, not too loud, but also give it the airflow it needs. And within the refrigeration compartment, it's soundproofed, and the compressor's on dampers to reduce vibration. And also, it's designed to reduce downtime, operating downtime because of active cooling. Essentially, it can, when you're in heating mode and the operating temperatures are at their coldest, a defrost event is likely to be needed. But the nice thing is we can reverse the circuit basically and put it into cooling mode basically, and that will heat the evaporator up and melt any ice that's built up. And so more of the technical specs, like I said, we have the EVI technology. Inside the outdoor unit, we actually have a backup heating element that provides 6.75 kilowatts of backup heating power, and that can be programmed to come in and operate in conjunction with the heat pump operation, or you can have it only operate when the heat pump when it's too cold for the heat pump to operate, which is -4. And you have control over whether when that happens. The electrical requirements are for the WPL15, the smaller unit. It's a 20 amp breaker for the compressor circuit, 35 amp breaker for the WPL25 compressor. You need 30 amps for the backup elements, and the controls also gets its own circuit that's shared with the HSBC, and I'll show you the electrical scheme in a little bit for that. And adapters come with for adaptation to 1-inch copper pipe. James has his hand raised. I don't know if he's looking to get in on the conversation.
Just wanted to say hi and sorry I'm late. Mike, you're doing great.
Great. Okay,
Hey,
cool.
James.
Howdy. Sorry to interrupt. Michael, carry on. I'll
No.
know when I'm supposed to interrupt you in a few slides.
Okay, gotcha. And so just back to the last, the unit has been tested to RE 550, 590, which is a chiller specification, but that chiller specification also has test points for heating. And that's there's some technical data later in the presentation that outlines that. So a couple of benefits that you can share with the installers, like just to hammer it home one more time, is supply heating, cooling, and domestic hot water, all one unit. They don't need a second unit or a backup heat source. Supply temperatures up to 149, great for domestic hot water. And monoblock design, self-contained refrigerant circuit. You don't require any HVAC technicians for the installation. The reduced noise from the inverter compressor and the modulating fan can install them in neighborhoods with strict sound requirements. With the demo units that we have running in our warehouse, you can put your ear up against the metal housing and you can hardly hear that even when the compressor is running. It's really impressive. And additional benefits for installers is the integration, which I'll get to in just a minute. And the cooling efficiency values are top tier with the integrated part load values, which is part of RE 550, 590 standard. 15.68 and 16.83 for the WPL 15 and 25 respectively, which are some of the top performers. And on the customer side, a lot of similar benefits. I'm not going to go over all of these again because I think I've hammered it home, but we are offering a great warranty with a 2-year on parts warranty and a 7-year compressor warranty in residential installations. Commercial installations, it's a lower warranty, but still sufficient in our view. And there's a lot of the same sort of benefits for the customers as there are for installers. Now the HSBC. So this is the combination tank that gets installed with it, and it has 2 tanks. It has a 72-gallon domestic water tank and a 25-gallon buffer tank in the unit. And as you can see on the front, there's a controller right in the center top, and that allows for control of the heating, cooling, domestic water system. That's where you control all your parameters. You can check on the operation of the heat pump. You can look at the process data from that and get everything you need from an installer perspective. There's a thermostat unit that can be installed in the living space that offers some similar parameters, but it's more of a customer-faced view. But this is where you get all your information. This HSBC combination unit also includes a three-way valve to divert between the domestic water tank and the buffer tank. It also includes the pump, the circulating pump to connect to the heat pump, and also the circulation pump for one heating circuit. And you'll even see that there's a second capability for a second heating circuit as well. Let's go to the next slide. This is the front of it off, just to give it a little bit more. You can see this split here on the side. That's the lower section in there in the insulation is the 25-gallon tank, and the top section is the 72-gallon domestic water tank. And this is the this on the left is the first or a pump for the first heating circuit, so that'll go to your manifold or wherever, fan coils. This is the pump that goes to the heat pump, and the diverter valve here is what diverts it into the domestic water tank, indirect coil, or into the buffer tank. And this is all the wiring, so this is where all of our sensors get wired up, and this is the main controller here. And there are even these ports here for a second heating circuit if you want to deliver to an additional manifold. This has a mixer, so it can deliver either a lower heating temperature or a warmer cooling temperature if you have different needs for different zones.
And that second heating circuit would require an additional pump?
It's a kit that we sell. I have a picture of it later in the slide. You can see this is actually the cutout in the installation for that. This is where the third pump would go. And the mixer gets mixed in, I think, above it, to mix it back into the supply and the return. So that's a kit that we sell, but it's easy to connect, and there'll be two more pipes sticking out the top center here when you install that kit.
And are the pumps similar to like a Grundfos 1558 type pump, or
They're Welo pumps, but in the same sort of class.
like a Star 21 kind of?
Well, they're PWM, or they're ECM pumps.
Okay. Okay.
I forget the model, but I think
Sure.
they're similar to I think like a Grundfos Alpha sort of pump.
Okay. Sure. And the top tank, you said it's like an indirect. So is there a submerged heat exchanger inside of it?
Yeah, I have a diagram of that later, but it's
Okay.
it's very similar to our SBB domestic water tanks, where there's the indirect oil.
Okay, got it. And the buffer tank is steel?
Yeah, there's no lining. It just acts as a hydraulic separator. Since the circuit's intended to be closed, you'll have the initial period of oxidation, and then it should just stop.
And the top tank is steel with enamel?
Yes. Yeah.
Okay. All right.
Yeah. Oh, yeah. Here you go. So you can see on the right side, you can see that coil inside the domestic water tank. And here's what it on the left looks like. Well, it's just an overview of all the connections. This number 3 and number 4 are for the second heating circuit supply and return. And your first heating circuit supply returns over here on the left, and then on the right, you're going to and from the heat pump. And we also have a domestic hot water connection kit that can provide connections at the top. You have your cold water in, your hot out, and even an opportunity for circulation, domestic water recirculation. And this is, from our perspective, this is great for a single family home. It can provide the hydronic heating, whether it's in the floor or in the walls, and also domestic hot water, showers, sinks, whatever. What you see down here in the basement is more of a setup, which I'll get to in a minute. If you don't want to use the HSBC, you can just use buffer tanks and any domestic water tanks you want. So that's another option. It's also good for multifamily construction. I'll show an example of units installed in parallel. If 4 tons of cooling, 50,000 BTUs of heating is not enough for you, you can group these in parallel up to 6 units to expand the amount of heat that is provided. So just to give a little more like of a 3D view of the installation, we have a short video showing this in residential, just kind of a feature overview of the WPL25. It's great for residential homes here. You can see the HSBC inside there. Just a short pipe run. All the electrical terminal blocks in there right above the connections. And it can be since it's so quiet, it can be installed right near windows. It's not really a problem, and also great for night operation. And it's so like I said, it's good for heating. It's good for cooling, and like I said, delivery temperature is up to 149 Fahrenheit, so it could even do wall-mounted radiators. And large-scale buildings as well. This is a unit system in parallel. If you have 2 units in parallel, the HSBC is not an option anymore. You'd need to use buffer tanks or domestic water storage tanks.
And then at that point, it looked like there was a different indoor unit, almost like a wall hung.
Where are you talking about? Here or a little bit after this?
There was a slide a little while back where you showed the
I think
2 bigger
the last
storage
slide.
tanks.
Oh, okay. Yeah, so
see, there's
that's
like right.
Yeah, that's actually a different module that we don't sell in the US, but it's that is a module that includes pumps and the controller. We have our controller, which is a little bit smaller than this, and I'll show you in a bit, but that's you have your controller there, and you need to install your circulation pumps separate from that, and run wire to it.
So you're saying if we're doing more than one, so 2 in parallel, then we
Yep.
can't use that buffer tank storage tank combo. So we're going to use our own storage tank buffer tanks.
Yeah.
What do we use to then circulate? And
well,
if this isn't available yet?
Sorry, what's not available yet?
This wall box you were saying is only available in Europe at this point.
Well, so we have a standalone controller with a set of relays, and you just wire those to your own pumps. Yeah.
Okay.
We're not actually planning on bringing this module. It's just this image is evocative of most of what we're able to provide. That thing.
Okay.
Not included.
So then that would be our own pumps, and would you pump the 2 outdoor units individually? Like each outdoor unit gets its own pump?
Yeah. I'll show you.
Got something on
that? We can skip there if that's what you're really interested in.
Yeah, we don't have to jump ahead if we'll get there.
Well, we will get there. I'll show you that. So here's just more for reference, but these are the heating capacities that we're working with, up to 50,000 BTUs, up to 23,000 BTUs on the WPL 15 cooling. We're talking 2 and 4 tons roughly, and these can all be referenced later. But the COPs are also quite high at these operating points.
The third one from the bottom, if you go back one, Mike, the A5 LWT 110, that is the cold climate AHRI efficiency standard, right, Mike?
Yeah. And we're the highest out of all the ones that list that on the Energy Star list.
So it's like 5 outdoor ambient and leaving water temperature of 110.
Yep. So yeah, compared to the Chiltrix and Enertech and Space Pack, we have the highest COP values here.
And we are unique in that I think we're one of the only ones who actually did the third-party AHRI testing and certification, right, Mike? I don't believe competitors are doing that.
I think the Chiltrix has the AHRI certification, which would require third-party testing lab. We went to the third-party testing lab and ran the RE 55590 test, but we did not go for the RE certification. So just want to make that clear. But these are independently verified values.
Thanks.
Yep. This is just another technical reference for the cooling capacity. I think it's particularly interesting. You can see with the enhanced vapor injection technology how flat the cooling capacity curve is as your ambient air temperatures increase, where with a non-inverter driven unit, that would not be the case. So I think that's quite interesting. And for the WPL25, similar values. For system sizing, it's still important, but I'd say perhaps less important compared to a it's a little bit easier, I guess I should say, compared to an on-off non-inverter driven heat pump, since this unit can modulate itself as long as you have the heating capacity that matches your design, the building heat loss at your design temperature. It will be able to handle anything above that while still minimizing short cycling. So you basically just have to do ideally we want a heat loss calculation done, whether it's to the manual J standard or maybe less rigorous, but still relatively accurate means to come up with a heat loss in BTUs per hour, kilobTUs per hour at a certain design temperature. And with that information, we can build our just our crossover chart here, where if you look on the right, we have on the blue line is the heat loss at each individual outdoor temperature. So ideally, we're looking at 65 Fahrenheit, we have no heat loss in the building. And as the outdoor temperature gets colder, we obviously the heat loss increases. And if we superimpose each of our units max operating curves at a capacity at outdoor temperatures, we can find the balance points for each unit and find at what temperature the unit is no longer able to provide enough heat for the building. And that's what these shaded areas are showing. And you obviously want the shaded area to be as small as possible, because this is energy that needs to be made up with a backup, whether it's our 6.75 kilowatt backup or with an additional backup that you might have to install as a secondary source. So for this particular installation that we found, or that we have for our example, which is say at around 0 degrees, we have a 40,000 BTU heat load. It would be obviously the WPL25 is the ideal install here, since the balance point is below 0, where it's only when it's colder than that are you going to be adding in supplemental heat. Where if you had undersized this and installed the WPL15, it would have reached capacity at 27 degrees, and anything underneath that is going to need to be supplemented by a different heating source. So, but anything above this value, so anything above 0, our heat pump is going to vary its capacity and provide exactly this calculated capacity, or the calculated capacity, and it won't be short cycling on and off where we might have that with a non-inverter heat pump.
And these numbers are not considering the 675 backup?
But yeah, so this is only using the heat pump. So in the controller, there are parameters where, so for this situation, you would probably want to set the backup element to kick in at whatever this value is here, the -1 degree Fahrenheit. And then, so once the ambient temperature is measured at something below that, it'll automatically ramp up that backup element to supplement it.
And then they'll be working in conjunction with each other at that point?
Yeah, down to -4 Fahrenheit, where at that point the heat pump isn't working anymore. So you'll be solely relying on backup heat or a secondary heat source.
Monovalent, right? That's the term.
Yeah, monovalent is more about the energy source. So like it's both provided by electricity, the heat pump electrically powered, backup element electrically powered.
And from a sizing standpoint, do you recommend sizing based on the heating capacity and not really considering the cooling? Or should we, some other manufacturers said size it to the cooling capacity is more important than even the heating side?
You can. That's certainly a possibility. It depends on what's more important to you. You would have to do a similar. We don't have graphics like that provided, but you could do the same sort of thing in plotting the building's energy demand based compared to the capacity.
From a cooling aspect?
Yes.
Okay. But generally, if we size it like this, based on the heat loss, manual J, we should be pretty safe.
Yes.
Okay.
I mean, and you can always just reference the cooling output at different values. We do have even this chart here. So I mean, it's pretty flat. That's why you can kind of, as long as you know that your cooling capacity isn't going to be more than 2.25 tons, you can use the WPL 15 as long as it also satisfies your heating demands. And all this information is in our manuals as well. But you have the same sort of situation here for the WPL 25. As long as you're not exceeding 4.5 tons, you should be fine. And one thing to keep in mind is it's not only the heat pump that factors into the heating system sizing, but it's also the means of delivery. So we can provide lower and lower temperatures. If we provide lower temperatures, water temperatures in the heating mode at least, the capacity increases and also the efficiency increases. So going with a floor heating system might be able to slightly lower the size of the unit. Either way, it increases the efficiency. So I mean, it's just obviously a reminder that lower temperature heat delivery is preferable in these sorts of situations. And just quick on, so this is our WPM controller. This is basically the control system that is in the HSBC. It's just extracted out and for a system that doesn't need or can't use the HSBC. You would wire in all the sensors and all the pumps into this unit, and this is where you would mount and control the system from. And the way this is on the heating side, we do it via setting of a heating curve. And basically, you take your design temperature. So like in Massachusetts, for example, our design temperature is around 0 degrees. I think it's -1, but for simplicity's sake, 0 degrees. And you ideally know your supply temperature that's needed in your heating system based on your hydronics or your wall-mounted panel radiators, whatever. And if you know that temperature, say it's you want to deliver at 100 degrees, you follow it all the way over and see where it crosses your design temperature. So right here, we're halfway in between the 0.6 line and the 0.4 line. So in our system controller, you just have to set this value to 0.5, and now your heating system will be able to deliver temperatures as ambient temperature fluctuates. It's just a way for it to kind of predict how it needs to vary the temperature delivery. So the heating
Is the
system,
outdoor sensor in the outdoor unit?
we have a separate outdoor sensor.
Okay.
Yeah, it comes with the WPM controller.
Okay.
And for mounting, we provide and recommend using kind of our T-mount setup, which suspends it above the ground. We learned a little bit of a lesson in our demo units that we installed about 7 years ago, where we installed them on a slab. It works fine, but with snow drifting and frost heave, it's not really ideal if you have a lot of freezing possibility. So suspending it like this has worked better for us. You can either use the T-mount, which you can see here on the bottom center. We also sell a wall mounting kit if you have the structural capacity for mounting this unit on the side of a building.
The T-rack is the custom and the standard rack that goes out with our premium sets.
Yeah, comes in the kit. Yep, and so this is what the unit, the back side of the unit looks like after installation. So we have our hydronic connections down in here. And I think in the video you saw them lift this door up, and these are where the electrical terminals are. So everything comes out the back here.
And I assume you guys are insulating the piping.
I mean, we don't provide the insulation, but the pipe should be insulated. Yeah.
Okay.
In the kit that comes with the premium set, you get both that ASWP. Mike, can you go back one? The premium set comes with that connections set on the top left, and then also the T-rack on the bottom.
Yep.
And isn't the premium set the only set you're offering at this point?
Yes, but you could buy the heat pump itself, the ASWP itself, and then like the wall mounting rack instead.
Yeah.
Or you could, forego racking if you wanted to install it on a concrete slab, as we'll see in the next slide. But as Mike said, if you are in a notably cold climate with snowdrift and or frost heave, we recommend strongly doing either the T-rack or the wall mounted rack.
Yeah. I mean, if you take measures to ensure that water's not gonna ingress underneath the slab and heave it up. I mean, you can do it on a slab, but you're just kind of you're bringing additional factors into it. But up to you. So if you were to do a slab, you'd need and if you're going to bury the piping. So I mean, this is actually what this housing is designed for: is the piping to come out and take a 90 downward into the ground. So you need to just do the pad like this. And this is the location of a condensate drain in the unit. So you'll need a hole to drain that down to below frost depth. And if you do it on a T-rack, like pictured here, just have a tube down there. We do have an optional accessory, which is a heating strip that wires into the heat pump and kind of dangles down into this tube to heat the condensate to prevent it from freezing. That's also an option. And here's visual. Actually, this is
Quick question for you, Mike. Is that heating strip something we have on either of our demo units here in Massachusetts?
yes.
Gotcha.
Yep. And here's what a 2-unit system looks like. And just for installation guidelines, I mean, this is pretty obvious with heat pumps. You need to provide adequate air circulation. So being in a corner is fine, but you don't want to put it in like a three-sided alcove because you might run into a situation where the heat pump is sucking in its own exhausted air and a thermal short circuit. And these are dimension clearance requirements. So 20 inches on one side, 40 inches on another, if you want to group them into arrays. And on the back side, so that the airflow is in this, as pictured, is flowing from top to bottom through the unit. A foot on one side and almost 80 inches on the exhaust side where it's blowing the air.
So would that include like a bush or something on that front 80 inches?
Yeah, that'd be fine.
A shrub or something would be okay.
Yes. Yeah, if you want to hide it, that's fine. Also important is, so an open field, like, so we say at least 12 inches. But you actually need to protect the intake side of the unit. Because say if this wall wasn't here, and you have a prevailing wind in this direction, you'll be increasing airflow over the evaporator in a way that the heat pump can't really predictably tolerate. So if you are gonna install it out in the open, you'd need to construct a wall. This is not to scale, this is probably a little closer than a foot, but something like this is what you would need. A house is obviously, if you install it by a house, that's totally fine. But out in a field is not okay. This is not really a concern for you. No installation within a third mile of salt water or the ocean, whatever. Just from a component perspective, they're not really designed to tolerate salty air. But I don't think you're going to have a problem with that in Colorado.
A consideration you should have in Colorado, though, is elevation.
Yeah.
These units are rated according to the installation manual and per our specs to work without alteration or elevation considerations up to, 2 kilometers or 6,600 vertical feet, right, Mike?
Yeah.
If you go beyond that, you can, but there will be reduction in both efficiency and capacity, right, Mike?
Yeah.
As such, if you go above, 6,600 vertical feet, you might have to tweak the WPM a tad, right?
Well, if you want that, we'd actually have to provide the control boards for the WPL. We need to have them special delivered from the factory with we need to change the fan parameters to actually run at increased fan rates. Basically like scale the fan curve upwards for all ambient temperatures. But it's certainly possible. If you think you'll be installing a number of heat pumps above 6,600 feet elevation, definitely let us know and we'll get you the heat pumps that you need. It's a little bit non-standard for us, but we can do it.
And we have done it.
Yeah.
Down in
Oh yeah.
Machu Picchu's our case study.
Yes, we install them at Machu Picchu. Also, we have installations in Austria where that's quite a common situation. And these heat pumps have been installed and work fine there also.
So you're saying that has to be set up from the factory or from Stiebel with the other board?
Yeah, well, it's the same board. It's just with the different with different parameters set.
And those are brought over from Germany that way, or that can be adjusted?
We can deliver them. We can deliver them from Germany that way.
Okay. Or what
Yeah,
about the stock in Massachusetts? Is that just the way it is? Those can't be adjusted?
We would have to replace the controller, the internal controller, but it's something we can also do in Massachusetts.
And if we were to use the standard model, we need to derate it, is what you're saying?
Yes.
And that's kind of still a gray area, how much we should be derating using the standard model.
I've asked that information. I have not received an answer on the
Okay.
percentage of derating. It's still an open question.
Okay.
That would be good to know.
Sure.
My town that I live in is 6,700 feet, which is pretty low for the mountains here in Colorado.
Okay.
So,
Would you say, Mike, if it's 67, that would be even a concern?
I mean, that's the max limit where we don't need to derate it. That's 2,000 meters basically. If you for higher than that, you start bringing in the derating, but it's mostly a linear phenomenon at that point. So if you're just above 2,000 meters or 6,700 feet, then it's not really derating at all.
as we're talking about elevation, I deal with some cold conditions. Can we talk a little bit about even additional auxiliary heat once you're below that -4? Does your control integrate with the auxiliary heat?
Yeah, so we have a relay in the controller that where it calls it's the second source second heat source relay, and when it knows that it's not providing enough heat or it's got to the point where it's turning off, it'll close that relay and you can hook that up to a circulator that's in your second source loop or whatever. So our controller can do the work of saying, we're not providing enough, bring in the second source.
Okay, great.
Do you guys have any piping schematics showing how you would like that second source integrated from a piping aspect?
I can provide that. We do have schematics, but not in this presentation.
Sure.
Probably just be direct pump into the heat source, or excuse me,
Like with-
distribution.
With like closed T's, like primary, secondary?
Close T is definitely a good way to do it, yeah. Or you can have a thermostatic diversion based on if it's not up to temperature. If the heat pump is providing up to temperature, divert it straight into the heating circuits. If not, divert it around into the backup source.
Okay.
But speaking of schemes, so here's our first one, which is the main one we think for a residential system. So we have our HSBC in the middle here with the controllers and the pumps already installed. So what the installer would have to do is run the pipes, the two pipes outside to the unit. You're going to need a TMP system or a TMP valve and an expansion tank, since that's not provided by us. But minimal install on that side. On the domestic water side, Similar thing, you got to run your cold water into the unit and your hot water out of the unit. Optional recirculation as well. And on the heating circuit side, the pump is in here and can just go straight to your heating circuits, however you have that wired up.
And would we need an air separator between the outdoor unit and the buffer tank?
It is nice if you put it at the highest point in of the system. Yes.
All right. So you would do an air separator over there. We probably need expansion and all the other air separator on the heating side as well.
Yeah. Yes.
Because I guess they're open to each other through the buffer tank. The outdoor unit
yeah, I mean,
to the buffer tank to the heating system.
Yeah, I mean, so you're basically going to have some accumulation towards the top of the buffer tank here, air accumulation in here, but eventually it will come out.
So maybe one air separator for the entire system and one expansion tank potentially.
Yeah, I mean, that's why we only draw the one expansion tank here, because this is all, yeah, one connected hydraulically. Yes.
Okay.
Okay. And just for customers who may have some anxiety about having a heat pump doing their domestic hot water heating, like in terms of recovery time. So I mean, these units are very well powered for reheating a 72-gallon tank. And so even if you need a 90-degree rise from a fully drained tank, you're looking at 1.4 hours, even at the coldest temperatures, to replenish your tank. At more average temperatures, you're looking at about an hour for the full 72 gallons. So pretty good recovery for the WPL 25.
Speaking of domestic hot water, the auxiliary may have to supplement domestic hot water on a very cold day. So that integration back to be able to supplement with auxiliary on the DHW.
Sorry, could you repeat that?
Just kind of the same thing on a really cold day. Let's say it's -10 outside. We need auxiliary supplemental heat for the heating load, but we'd also need that for the domestic hot water at that point.
If the 6.7 kilowatt heating element is not enough for you, that will still work and provide your domestic water.
Okay.
I mean,
that's true. I mean, the 6.5 probably could help keep up with the domestic pretty well. I would agree with that.
Yep.
And let me think here. So the max DHW temperature is going to be the 149.
Yep.
Okay.
Okay. So the back side of the heat pump, this is with the back covering pulled off. You can see this is the inverter controls here. Below that are the terminal blocks that we wire into, and we have our supply and return connections, even a drain connection here. But these copper tubes are actually they're John Guest quick disconnect fittings, but we supply adapters to copper pipe and just plumb out to wherever you need to go from there. This is a close-up view. So it's really critical for our air-to-water heating systems for all the air to be flushed out. From the very beginning, we did just discuss venting, but from the beginning, it's important to get the air out. So it's also like from a corrosion perspective, particularly in the buffer tank. So installing air separators in line is a good idea, or well, in this way, it's not a good idea. Something with an increased cross section is a better idea to slow liquid down, let the air bubble up and get trapped. So I'm glad we did talk about that previously. This is a good idea to vent the system.
And just a couple questions. Is there a certain ratio that you'd like to see the glycol not go over, like 40%?
It can go up to 50%. That's fine. I mean, you will, it does, the more you add, it does derate the heating capacity a bit.
Sure.
But 40 should be totally fine.
And
Can go
let's
up
say
to
you
50.
didn't want to glycol the whole house. Do you have any suggestions for separating the glycol?
You can do a flat plate heat exchanger. It would just require a little bit of extra wiring internally in that. I mean, if you want to, you put a flat plate heat exchanger, you'd need another pump on this side, and the relay from the controller that's running the heat source pump would also need to be wired into the pump on the other side of the flat plate heat exchanger. So it is possible, but it would require a plate heat exchanger.
And that relay would be able to handle 2 pumps running at the same time?
Yes. Oh yeah.
And then is there a certain pump that you'd want us to use to the outdoor unit?
No, it's though that one is we're not modulating the speed really. Actually we want to have I think that's in the manual. The target is 4.5 GPM for the WPL 25 and 3 or so for the 15.
Okay. So that could be a standard 3-speed pump, effectively.
Yes. Yes.
Okay.
And the
So
pressure
with
drop,
my
I think, is like 1 or 2 PSI at those flow rates.
so with my ground source systems, they're pretty adamant about knowing the flow and installing some flow meters. Do you recommend that on the we'll say the source side of this?
We have a flow sensor inside the unit already detecting all that. So it's fully self-contained, all the process data, sensors, pressure sensors, flow sensors, everything's already there.
But you don't need to know like that you have that 4 gallons or whatever you just said, 4 gallons a minute.
It doesn't need to be exactly 4 gallons, but that's like the ideal. So our system will detect the flow rate and modulate its capacity based on the information that it's recording.
Okay.
All right. So that's the schematic for the HSBC. Minimal wiring and piping needed to be done. Did these connections already. Talked about this. This is a wiring scheme. So we have a number of wiring schemes that we can provide for you. This particular one is for the WPL in combination with the HSBC. So this is your mains power here. So it has 3 different circuits that need to be run to the heat pump, and one is also shared with the HSBC. And this is the electrical supply for the compressor. So this would be either a 20 amp or a 35 amp, depending on the size. If you're doing the backup, that's a 30 amp running to this terminal block, and the 15 amp for controls goes to the heat pump, and it also gets wired over to the HSBC. And within the internal controller inside the HSBC, a 3 wires need to go to the communication terminal on the heat pump. And this FET is the room thermostat that the customer can have control of. And if you're actually looking to do cooling, it's required to be installed in the living space, as it has a humidity sensor, so like dew point control sort of functionality. So if you're doing cooling, needs the FET. And we don't have electrical schemes for the other for systems without the HSBC, but just to this top row is all the low voltage connections. So this is your outdoor temperature sensor. This needs to be wired into these two terminals. This is a cooling return temperature sensor here that needs to get wired in. But these are all your pump relays, and we have a document that explains how all this stuff works. But these are for like your heating circuit pumps, and your source pumps, domestic water charging pumps. So everything can be everything gets wired in here.
So would some of that be pre-wired then, considering
Yeah.
some of the pumps are integrated? Okay.
For the HSBC, we don't list them here because you don't need to wire them. This
Sure.
is everything that you would have to wire. So you would have
Okay.
to wire in this return sensor pump if you're doing cooling. This is the outdoor sensor that has to get wired in, room thermostat, and wired to the WPL. But everything else is already taken care of. This is what a system looks like if you do not have the HSBC tank. So similar appearance, you have your WPL. This is the WPM controller by itself. So all those same relays here are right down here, get wired into. This is your outdoor sensor. Place this outside on the wall. That gives feedback on like outdoor reset and that heating curve that I explained earlier. But in this case, we have our fluid going to, it actually branches out here. So this pump wired into, this numbering is for the WPM. So this is pump 2.6 gets wired to relay 2.6 on the electrical scheme here. This is for the buffer charging. 2.8 gets wired in there, relay 2.8. That charges the indirect coil in the domestic water tank, and everything returns to the heat pump. Relay 2.3, same thing. That's going to your heating circuit. And if you had a second heating circuit pump and you wanted to do that as well, there's 2.3 for the first heating circuit. You have 2.4 for the second heating circuit, 2.5 for a third heating circuit, and if you have a fourth or fifth heating circuit, we have an extension module that gets wired in, it's basically the WPM doubled over, and you can wire them together. And that's the same thing if you had multiple heat pumps. If you have more than if you have more than 2 heat pumps, you'll need the second module in order to wire everything into it.
How many heat pumps? Over 2?
Over 2 heat pumps, you need the extension module. So that's so this is what a single unit with buffer and domestic system looks like. This is what 2 or more unit system would look like. Same kind of thing as the last one. And this is I'm only showing for heating here, but you can do it for domestic water also. We can provide you the schematics for it. But we have 2 different heating source pumps. So one gets wired into one heat pump, one gets wired into the other, or plumbed into the other. Everything gets controlled by the WPM controller. We have our outdoor sensor, and they branch in back together to go into the buffer tank. And this is where you could branch out to the domestic water, just like the other one. And you can have 1 to 5 heating circuits depending on your needs. also.
And you guys are showing pumping away from the heat pump units. Is that recommended that way?
Yeah, it's recommended, but you can put them on the cold side if you want.
Okay.
Just a little bit of a getting away from the design and schematic. I'm sure you guys are aware of, you know, a lot of our competitors, where it is pretty standard now to have an inverter with variable or an inverter compressor. But not all of them have the EVI technology, which we really think is one of the most promising and standout features of our unit. But I talked about this a little bit earlier on the cold climate efficiency test. We have the highest COP value. This is for the 25 WPL 25 at 2.77. And at this benchmark, this is using our unit at as like a baseline capacity, the Space Pack, Chiltrix, and Enertech. At those COP values that you see here, they are lower capacity units at that testing point. And similar information. So these are the max heating capacities. I think probably the most interesting is the IPLV values. So this is the integrated part load value, which is the kind of like the seasonal cooling performance. So the Chiltrix is the best, but ours is still quite a decent number. Particularly if you look at the full Energy Star list, I think ours is the second highest. Chiltrix's device, I think, is designed a little bit more as a chiller first and heating unit second. So this just kind of shows the difference in design intention of our unit. This is not so relevant to you. This is our Mass Save rebate program. We have Massachusetts has a program for rebates for air to water heat pumps. I'm not sure if there's something similar in your region. Do any of you know if there's any rebates available?
Yeah, I'm not sure.
Okay. So in Massachusetts, it's $2,500 per ton. So it's I think up to 4 tons. So quite a bit of money is being offered by the state. So if there is something in Colorado, it might be a very beneficial thing for you in terms of helping to make that sale. And this is just an overview of all the stuff in our heat pump catalog at this time. Something I wasn't able to really explain before, but this is that mixer pump circuit that for the HSBC is for the second heating circuit if you are looking to add that. And this is the pipe connection kit if you're looking to do domestic. We'll have the domestic water connections come out of the top. The connection points are in the back. So this helps in terms of access. But everything else is we've already really discussed. This is the WPM. The WPE extension module is the same thing, just without the display. And this is the digital thermostat that gets installed in the room, the conditioned space.
The WP is only necessary if you're going beyond more than 2 WPLs in a circuit.
Yep.
And you said up to 10?
Up to 6.
Up to 6 heat pumps, up to 5 heating circuits.
Okay. And if you have multiple heat pumps, let's say 6, are they going to stage each other and rotate?
Yeah. Yeah, so the logic ramps up brings them in gradually when the demand increases.
And that's managed through the WPM.
Yes. And there's some like dynamics control about how it does that, but that's all those parameters you have control over.
So if you had 6, is there a possibility of using one monoblock outside that's sized appropriately? Or do you have to have 6 individual monoblocks outside?
Sorry, what do you mean?
So if I had 6 inside units, the heat pumps, and then one, is it possible to have one monoblock outside that's sized appropriately, or you have to use 6 monoblocks outside?
What do you mean about indoor heat pump units?
Well, I mean,
So
the
Jeff,
go on.
maybe there's a little confusion. So when the 6 is the outdoor units,
Yes.
and if you have more than one outdoor unit, then you can't use their indoor unit anymore. You have to use an aftermarket buffer tank and domestic hot water indirect coil tank.
Gotcha.
So it's going to be staging all 6 outdoor units, and then we'll have to size the indoor buffer and domestic tank separately, and we'll have to do our own pumps, and it's definitely a little bit more involved. Where if it's just one unit outside, one unit inside, then we can use that HSBC, which has everything integrated into it.
Yep.
That highly integrated HSBC is definitely one of the things that sets us apart. I don't know of any other heat pump manufacturer that has the buffer tank, the domestic hot water, the controls, and the pumps all built into one highly integrated tank system.
Well said.
One thing I'd like to just touch on briefly would be solar thermal integration.
Okay.
Downtown, looks like Dave Finn has a question.
Okay.
Quick question. If you don't use the integrated unit, do the efficiencies change?
Well, yeah, I mean, the efficiency depends on the surface area of the heat exchanger and the flow rate through it. I mean, so you're always going to get different efficiencies. I mean, the ones that are published by or done according to the RE 550 590 standard don't even include the buffer tanks on any units, not just our unit. It's just the heat pumps performance at the test points with a constant flow of water over it without considering any of the parameters of the buffer tanks. So yes, it's always going to be lower, but the more highly you integrate the buffer tank solution with the heat pump solution and match them for each other, the closer the efficiency is going to be to the published efficiency. So the way we designed the HSBC 300 is to have the right buffer tank size, the right domestic water indirect coil size, and pump sizes to match up as well as possible.
Thanks. I was partially asking that because the domestic tank size in that unit seems pretty big for a lot of the, market around
Sure.
here. And I'm just wondering if a standalone smaller tank size affects anything.
Well, you would want to make sure that you would want to know the capacity, the maximum capacity of the indirect coil, and it has to be as big as the maximum heating capacity of the unit. In that case, you're definitely gonna run into efficiency losses.
Okay, thanks.
And Dave, maybe the 71-gallon domestic hot water tank isn't too big because we need some extra storage mostly because we're not able to send a ton of heat into there all at once. Like with a gas boiler, we could potentially send, 120,000 BTUs into a 70-gallon tank, but here we're only sending, 50,000 BTUs. So it's nice to have that extra storage so we can have the capacity. And especially in the event when it's really cold outside, we're only heating that with the 6.5 kW element. So another reason to have some extra storage on the domestic side.
That makes
In-
sense.
In addition to that, it's not spending all of its time doing domestic hot water. It's also needing to provide heat to your building. So there's so it's needing to do that and do domestic water heating. And in the summer too, it needs to switch between cooling mode when there's a call for cooling, and also if domestic water has a demand, it needs to switch off of cooling, reverse the circuit, go into domestic water. So all of those things come together.
So in the summer, if it's cooling, chilling the water down, then it has to just reverse the process if there's a domestic hot water call and just heat that chilled water right back up.
Well, it's cooling the buffer tank, so that's why we
Okay,
have
right.
we have that diverter valve in there. So it's cooling the buffer tank. A domestic water call for heat comes. It changes the three-way valve to divert the fluid
Not
into
to go
the
through the buffer anymore.
yeah. It'll put it through the indirect coil in the domestic tank. It'll
Okay,
reverse the
bypassing
heat
the
pump
buffer.
circuit. Bypass. Yeah, so they're
Okay,
it's not in series or anything. So
yeah.
that way you can keep your cold buffer tank even while it's heating the domestic tank.
So that kind of leads me to another question. I see you guys are now offering a buffer tank standalone, the SBP here. It's a 52-gallon buffer tank.
Yep.
So would we need some kind of external diverting valve to divert? And I think it was in the drawing maybe to divert the buffer tank. And
You can either do you can do it via pumps or valves.
Okay.
Really, I mean, with the way that our relay is designed, this 2.8 could be powering a pump, or it could be powering a three-way valve, also energizing that to divert it. There's a couple of, it's really up to you as long as you're utilizing the logic of the controller. But in this
Okay.
schematic, there is no three-way valve. It's just because our
Sure.
unit, especially if there's only one unit installed, it can get more complicated with two units. But with one unit installed, it's only going to do one of these relays at a time. But if there were two units installed, like this particular system, you can actually tell if we're doing domestic water, you can tell this, you can allocate it in the controller that this heat pump right here, while also charging the buffer tank, can have a branch off here to do domestic water. And this unit can keep on heating while this one does domestic hot water. You can have some like parallel operation.
Okay.
Or you can dedicate both heat pumps to domestic water heating. You can do all sorts of stuff, but yeah, there's some versatility there.
Are there some guidelines for sizing the buffer when more than one heat pump is used?
Yeah, so we have a minimum. 'Cause I actually didn't explain this. So we actually require a buffer be installed in every single system, and that's from a safety perspective, like an equipment safety perspective. In that in the winter, these units are likely to enter a defrost cycle, and in the defrost cycle, it's essentially entering cooling mode briefly so that it can melt the ice on the evaporator, and that cools the condenser, the plate heat exchanger and the heat pump down. And so it could freeze if you don't provide it with enough heat. So that's taking heat out of the buffer tank and preventing freezing of the condenser. So first of all, we require a buffer tank and 25 gallons of buffer storage per heat pump. So in this system, we would recommend at least 50 gallons of buffer storage. And that's why, I mean, one of the heat pumps or one of the buffer tanks that we offer is the 58 gallon. That's not on the list here, but we also have a 25 gallon buffer tank and a 110 gallon buffer tank that you can get from us.
All right, so 25 gallons per unit.
Yeah, that's the short way of saying my long-winded answer.
Okay.
Quick question. What is the dimension? What are the dimensions of the HSBC? It looks like it's pretty tall and the connections come off the top. So that is just a concern, I guess.
Yeah, let me just get those dimensions here for you.
It is quite tall.
Yep. So it's 75.5 inches tall, 27 wide, and 36 deep.
It's quite heavy too.
It is. Oh, so I didn't explain that part. It can, for installation, easing installation, be separated into two parts. That buffer section or the domestic water section can be separated and to make it easier to get it into tighter spaces. In the longer term, in the next few years, we're actually looking to convert from a glass lined steel tank and get into stainless steel domestic water tank, which would make it lighter. We're aware of that it's pretty heavy, but again, it is an all encompassing solution.
And have you guys thought about integrating solar thermal on this one?
Not into the HSBC, but it certainly could be designed into the system as long as you're ensuring that the hot water temperatures that you may encounter in solar thermal aren't being fed into the supply, excuse me, of the heat pump. So you don't want to be bringing water back to the heat pump that's like above 135 Fahrenheit or so.
So probably on the system side of the buffer tank
Yeah.
injection kind of thing.
Yep.
There's no logic in the control to manage that though, is there?
Not that I've seen, no.
Okay.
So that's it from me. Sorry, what do you guys have? Any more you want to talk about?
So you mentioned multiple temperatures, heating circuit 1, heating circuit 2. So you could have a lower temperature on heating circuit 2. So
Yep.
like heating circuit 1 could be panel radiators, heating circuit 2 could be the radiant floors.
Yep.
And then you can set a separate temperature for heating circuit 2. Would that run on its own separate outdoor reset curve?
Yes, it does. You have a heating curve for each heating circuit.
Okay. And then 2 would be 2 temperatures is pretty much the max at that point. Unless you did it externally.
No, you can, heating circuit 3 also has a mixing capability, so you can mix that down to its own temperature as well.
So we have a heating circuit 3 within that tank unit?
No, not within the tank unit, but outside the HSBC. If you don't use the HSBC, with the WPM controller, you can have 3 heating circuits.
Okay.
And that third heating circuit could be a mixed heating circuit as well. with its own
So you
set
could
point.
utilize that mixing station thing you showed in the last slide without that integrated tank unit.
No.
Okay.
Sorry. But you can, but it's that principle you done outside of the HSBC. I mean, you would have to provide the components, you would have to provide the pump and the mixer, but the controller has that logic built in.
Okay. So we probably have to use a certain type of actuator or mix motor to be able to be compatible with the control, I would say.
Yeah, I think it's a 4-wire one with like directional control.
Okay. And if we get
Because
down into
it'll find its own point that it wants to be at.
okay, like a floating action kind of mix.
I think yeah.
Okay. All right. Yeah, that was pretty good.
All right.
Great.
Well, I think, yeah, unless there's any more questions, let's wrap up for today. And thank you guys very much for putting this together for us. Thanks everyone for logging in, and yeah, have a safe day. We'll talk to you soon.
Sure thing. My pleasure. Thanks for your time.
Hey, thanks for having us. And sorry I was late. I'm James. I'm the Western Regional Sales Manager, and it was great hearing all your questions. And thanks again to Mike for running the presentation.
Happy to.
Yeah,
Thank
thanks
you.
everybody, and have a good day.
Sure thing. You too.
Bye.